Hello, so allow me to introduce myself. My name is David Humphrey. I'm going to be your chemistry teacher today, and I'm going to teach you about the concept of electrolysis. So electrolysis, I think, is best understood primarily by understanding the acronym oil rig. Let's take a look at oil rig for a bit. Oil rig. So what is oil rig? What does it mean? So let's take a look. So first you need to understand oxidation is loss. So what then does rig mean? Well then, reduction is gain. Now I know that might sound opposite, but you have to remember not all concepts about chemistry were solved in the early days when they were forming the concepts about what to mean everything. So that I believe is important to understanding electrolysis. Oxidation is loss, and reduction is gain. So what does that mean? Well, it means with the concept of electrons. So for instance, in table salt, which we will explore further, reduction is gain. It gains electrons. Electrons have a negative charge, so that's considered being reduced. Oxidation is loss. It loses electrons when something is oxidized. So we'll explore table salt in a bit more detail. So with oxidation being loss and reduction being gain, where might that be applicable? Well, in the dissociation of table salt. In table salt, you see here the Na and Cl, which makes up table salt, splits off into Na and Cl. The Na oxidizes and the Cl reduces. The sodium loses electrons and the chlorine gains electrons. So let's express that in the equation here. So we can see that the sodium is positively charged and the chlorine is negatively charged in the table salt atom, table salt molecule, but then becomes its normal state when it becomes its normal element. So a question you might have is, why is it 2 NaCl goes to 2 Na plus Cl2? Well, that is a topic relevant to another subject in chemistry I'm not going to fully discuss with you, involving halogens and electron placement. That isn't entirely relevant to this topic, but just appreciate it for now. So 2 NaCl goes to 2 Na plus Cl2. So what's important to be remembered in this equation is that sodium is the element being reduced. It's going from positive 1 to 0 in terms of its electrical charge. And chlorine is being oxidized. It is losing an electron. Sodium's gaining an electron, and chlorine is losing minus 1 to 0. An important thing to remember about the oxidation reduction process is it doesn't happen on its own. Sodium chloride doesn't go naturally into its sodium and chlorine atoms by nature. What makes the electrolysis happen? Well, that is the result of electricity. So, since table salt doesn't naturally go into its sodium and chlorine by nature, how then does electricity move it into its sodium and chlorine? Well, for that, we should be considering two half reactions. What happens to the sodium part of the sodium chloride and what happens to the chlorine part of the sodium chloride. We have the chlorine half reaction. We have the sodium half reaction. So in order for this process to happen, we have here a battery, an electrical force which allows this to happen, which allows table salt to become sodium and chloride. So we have here the cathode end, which will pull electrons from chloride, oxidizing it. And then we have the anode end here, which will push electrons to sodium, reducing it. So for that we should understand that there are two half reactions that occur within the reduction of the fact that table salt goes into its native elements here. So you have here the reduction, the oxidation here of the oxidation of chlorine, where 2Cl minus goes to Cl2 plus 2 electrons. And then we have here the sodium reduction, where 2 sodium plus 2 electrons go to 2 sodium in its elemental state. So we have here two half reactions that occur that allow table salt to become its two native elements, and this overall is what electrolysis is. In the case of table salt, it can separate it into its native sodium and chloride.